All right, so we are on to our last weather and climate unit for the year. And these are our notes. So get ready to start taking some notes. Reminder that you can pause, rewind, and fast forward the video as needed, and you can rewatch it to make sure that you are getting enough time to write each slide and also so that you're hearing the lecture. So let's start by talking about what the atmosphere is. We've talked about the atmosphere in our previous unit about the 5 spheres, but we know that the atmosphere is all of the air around us and it has many benefits to us. It traps the heat using greenhouse gases, and that keeps Earth warm, which is able for us to live on it. If it wasn't warm enough, we wouldn't be able to sustain life, just as if it was too warm, we wouldn't be able to sustain life. So the atmosphere helps us monitor those temperatures and keep it at a livable temperature for us. Another thing the atmosphere does for us is it absorbs the rays from the sun. The UV rays can be extremely harmful from the sun. If we did not have several layers of the atmosphere to protect us, we would not be able to sustain life on Earth either. So the atmosphere is very, very important for our existence. There are 5 layers of the atmosphere. The first layer is the troposphere. The troposphere is the layer that we live in. Water vapor is restricted to this layer, which means that weather occurs in this layer. If water vapor is only in this layer, then weather cannot occur in any other layer. So it is the closest layer to us, and it's where all of the weather occurs. The second layer of the atmosphere is the stratosphere. The stratosphere is going to increase in temperature due to the UV rays coming in. It absorbs some of those UV rays coming in, and that's what's going to cause it to get a little bit warmer and warmer and warmer. Now, the ozone layer is right in the middle of the stratosphere, and the ozone layer is important because that is the section of the stratosphere that takes in those UV rays from the sun. The next layer is the mesosphere. It is actually the coldest layer of the atmosphere. And what's ironic about it is it's coldest layer, but it also burns up meteors. So you're probably thinking, how can it be hot enough to burn up meteors, but yet be the coldest layer? Well, what happens is the really, really cold molecules will scrape up against the other molecules that are brought in and cause enough friction to burn up a meteor. So if it wasn't for the mesosphere, we actually would have a very pocked Earth with holes everywhere because the meteors would just come down and scar Earth, for lack of a better word. So the mesosphere is pretty great because it will absorb some UV rays, but the stratosphere is going to absorb most of them, and it can burn up meteors because it is so cold those particles interact and cause friction. Next, you have your thermosphere. Your thermosphere will absorb some X-rays and gamma rays from space, which again protects us because all that radiation is not good for us. So the thermosphere will take in those rays from space. And then finally, your last layer, which is your exosphere. It's going to have extremely thin air, and it's going to be a perfect home for satellites because there's very little friction. So they're able to just move about very freely. So lots of satellites are held in the last layer of our atmosphere, or the exosphere. And the exosphere is composed primarily of helium and hydrogen. All right, greenhouse gases. There are 3 key greenhouse gases. That's carbon dioxide, methane, and water vapor. And these gases are in our atmosphere. And what they do is they take in heat or energy from the sun and they trap it. And when they trap it, they will keep Earth warm. And they call this the greenhouse effect because these greenhouse gases act very similarly to a greenhouse. A greenhouse is a large glass building where plants are kept inside. And what happens is the sun beats down on the clear glass greenhouse, and it will get the energy into the greenhouse, but then it traps it. It keeps it in there. And that's what keeps your plants warm, which keeps them surviving. So the gases in the atmosphere work the same way. Now, there are 2 ways we get greenhouse gases. One of them is when humans burn fossil fuels for energy, we release greenhouse gases into the atmosphere. Another one is land use. Trees absorb CO2, so the more trees we have, the more CO2 that's going to be put into the air. If we cut down a lot of trees, then that CO2 is not being taken in by the trees. So let's go all the way back to photosynthesis. Photosynthesis is a process where plants make their own food. Plants are going to take in carbon dioxide and give off oxygen. Us as humans, we're the opposite. We are going to take in oxygen, but we're going to give off carbon dioxide. And that carbon dioxide that we give off is what's going to be taken in by trees and other plants. So if we cut down tons of trees, there's not as many trees there to take in the CO2, which leaves more carbon dioxide in the atmosphere, which means there's more bubbles to catch the heat. The more that there is to catch the heat, the warmer it's going to be. And that's where global warming becomes an issue, because if it's too warm, we cannot survive. So we have to make sure that we have enough greenhouse gases in the atmosphere, but not too much. Atmospheric equilibrium. The idea of atmospheric equilibrium is to establish a balance from the radiation that's coming in from the sun and then the radiation that's getting re-radiated back out from Earth back out into space. So we take in some of that radiation. The atmosphere will absorb some of that radiation. Some of that radiation will make it all the way down to the Earth's surface. And then some of it will get re-radiated right back out to space and pushed right back out. So there's a balance. The amount that's coming in has to be balanced with the amount that's going out in order for things to be at equilibrium. Now, we as humans can affect this balance by burning fossil fuels. When we burn fossil fuels, we can disrupt this equilibrium of the amount of radiation that's coming in and the amount of radiation that's going back out. Deforestation, again, that same idea, cutting down trees, it's going to contribute to how much carbon dioxide is remaining in the air. And then finally, this very fun word, chlorofluorocarbons, or known as CFCs. And chlorofluorocarbons are not good for the environment. Some things that used to give off chlorofluorocarbons, some old refrigerators used to. I think nowadays they make them differently so that they don't have chlorofluorocarbons coming off of it. And arsenal cans, hairspray cans, used to have chlorofluorocarbons in it. So they've tried to design things to avoid CFCs from getting into the air. Some things that's going to be affected by upsetting this equilibrium is the weather. We may not have, steady weather if this equilibrium is upset. Farming could be an issue because if you don't have ideal weather, then your crops don't grow because it's too dry or it's too wet and they die. So that's definitely going to be impacted. And then finally, your sea levels. How high or how low your sea levels are is going to be affected by this idea of equilibrium. So it's important that we maintain this equilibrium at all times.